Ladies and gentlemen, our eminent speaker, Mr. Kumaravel, is a Senior Manager of Product Engineering at Wabtec Corporation, India. He works on product design and new product development in Transit Business Division of Wabtec for the past 9 years, with experience in fire detection system, passenger information system, brake systems, and couplers. Prior to this, he had worked in automotive and nuclear power industry. He holds a master's degree in engineering design from College of Engineering, Anna University, Chennai, and an MBA from IIM Bangalore. His interests are in innovation, new technologies, and sustainability in mobility industry. And a very warm welcome to you, sir, for your presentation.
In the recent decades, the world has advanced so much that the dream is becoming a reality in smart manufacturing. Welcome to additive manufacturing, which is the fourth industrial revolution in the making. I am Kumaravel from Wabtec India, and I will take you through next 15 minutes on the additive manufacturing and what Wabtec can offer to railway industry from additive manufacturing. The engineering industry has manifested a growing interest in smart and new manufacturing technologies. Additive manufacturing is one of the innovative technologies which has reached their broader adoption, and it has made its mark in various industrial sectors as well as railway industry. The core principle of this method is that materials are added layer by layer to form complete part rather than machining from a larger raw material object during the manufacturing process, which is in the case of conventional manufacturing. This method enables wide range of opportunities, which we will discuss in coming slides. With various additive manufacturing methods has evolved over last few decades, let us discuss about few methods alone in brief. The photopolymerization or the stereolithography process uses a laser beam to trace the cross section of the part on the surface of a liquid resin in an immersed bath. The other material jetting method, the part or material is deposited from a nozzle which moves across the build platform. The material layer are further solidified using the ultraviolet light in this method. Whereas in binder jet, we use glues between layer to join the metal with a post-treatment process. The material extrusion or fused deposition modeling method is used for polymers in which the extruded wire is used to form the part. In this method, the fusion is achieved by heat. The next last one which we'll be discussing is on powder bed fusion, which uses laser energy to fuse the material powder together over layer by layer. Let us move to process and benefits of additive manufacturing. The first step of additive is to design a part in a computer-aided design environment, which is CAD environment, and process it into a slicing software where the parts are made into thin layers. The second step is these layers are further printed into real part in the additive machine with a suitable technology which we discussed in previous slide. The last step is the printed parts are removed from the machine, the extra materials are removed, cleaned, surface treated, which is depending on the part requirement or the design requirement. Additive manufacturing enables manufacturing complex parts that wouldn't be possible in conventional manufacturing process at all. As the method directly uses CAD model and not any special tooling required, the lead time is reduced with this method, and this complements the agile manufacturing process. Already 3D printing have completely revolutionized the prototyping industry. Now the 3D printers have started revolutionizing the production sectors where the complex parts are required to be manufactured. Additive manufacturing is part of Industry 4.0 with integrated smart technologies and production systems to drive innovation and deliver cutting-edge solutions. Let us go through the application and few of the use cases of Wabtec additive. Here are some of the quick examples of printed parts ranging from prototyping to tooling to fit up. The first one is the battery housing and the second one is the housing or an inverter, which was printed for battery electric locomotive application. The middle one is a turbine wheel for a new development in turbo machinery application. A number of parts have been printed for the tooling application and mock fitment trial as part of product development process using additive technology. Building these prototypes help to avoid the tooling cost, expensive iterations in the design process, and the lead time required. The additive manufacturing overall helps in a rapid design iteration, which we will also see in a use case in the coming slide. Overall, the additive manufacturing helps in improving the design quality and shortens the product development cycle, thereby reaching the market faster. So here is the first use case. The component under discussion here is an exhaust cover subjected to continuous cyclic load which had failed in testing in the past. So the stress analysis of the part was studied and the existing manufacturing method had limitation in the design to achieve a complex cavities and material thickness. The exhaust cover was further redesigned suitably to manufacture by a multi-jet fusion additive technology. The complex cavities and protrusion were possible to the adopted design thanks to additive manufacturing technology. With no time, the part was printed, tested for endurance cycle and was validated successfully. Let us move to second use case. This example is on use of additive manufacturing to carry out multiple design iterations to find out the root cause of assembly issues and converge on the appropriate design. 3D scan was performed on the existing manufactured bush to capture the geometry profile which had an issue in the assembly. The profile was studied with mating assembly component to observe the interference. Multiple parts were printed with varying profile of the bush to identify the best fit of the assembly. The final required profile was concluded by this iteration in a faster and cost-effective way. This would have no way been possible in a conventional manufacturing method to reach the conclusion in such a shorter span and without any major tooling requirement. The final design was implemented in the product successfully. The third use case is on aluminum manifold assembly, which had complex machining and number of components has been reduced to one part through the design excellence of additive by the Wabtec team. This process enabled weight reduction by more than half from the existing design, with eliminating the complex machining process and assembly process, leading to material saving, cost reduction, elimination of tooling requirement. The reduction in number of parts and assembly also led to increase in the reliability of the product. The solution also helps in lowering the life cycle cost of the component due to less replacement parts in the assembly. The Wabtec's principle of delivering sustainable product to railway industry is once again proved with this lower weight and high reliable brake control assembly using additive technology. Coming to spares and services business, railway products have longer service life. Over the years, the parts become unavailable and become obsolete due to the outdated parts or manufacturer doesn't produce these parts anymore. In order to maintain high service level, the spare assets need to be stocked increases due to the fact that the demand of the parts are difficult to determine with certainty. Managing spare parts is one of the key issues in railway industry. For fewer order batch quantities, it is not at all economical to make the tooling. Hence, companies end up ordering high quantity of spares than required and are those occupy significant space in the warehouse as inventory. Additive manufacturing can help in faster, efficient, and quality fulfillment of the obsolete low volume parts. With Wabtec's strong competence in railway industry and with the in-house skills in additive manufacturing, design, and reverse engineering technologies, the supply uncertainty and obsolescence issues can be addressed effectively. with the low volume products manufactured by additive method, which leads to shorter lead time, making the inventory turnover ratio higher, thereby reducing inventory investment required in the spares warehouse. Let's move to the last part of the presentation on Wabtec's competence and capabilities in additive manufacturing. Wabtec has invested on wide range of machines to print various materials, size of parts, and capacity. The direct metal laser melting machine, which have been able to print inconel and stainless steel with sizes as big as 350 millimeters. The metal jet binder machine can print stainless steel materials of size up to 390 millimeter. We have access to upcoming metal laser printing machine for aluminum for bigger size up to 850 millimeter, which is again a metal laser melting solution. Different polymers printing machines with Wabtec can handle different requirements and materials. Parts can be printed to a size of as big as 1.2 meter with wide range of polymer materials like nylon, polycarbonate, polyacetate and various polyamide grades, and also includes the polyamide with glass-filled composite. Wabtec is part of the ecosystem of additive manufacturing and have access to latest machines, technologies, and developments in this area. So let me take a minute to summarize on how Wabtec makes a difference to railway industry through additive technology. As an organization, we have strong understanding of the railway requirement combined with additive competence developed over years with the design, materials, and process knowledge. The knowledge, best practice, procedure, standards, and measurement technologies required for additive manufacturing has been evolved in the organization. With the investment in latest technologies, printers, and competence developed over time, Wabtec is your right partner for additive solution for railway industry. Thank you.